right, so the first question we have here in the past question says that we should, if f squared, we are told that if f squared plus y squared minus 2x minus 6y plus 5 equals to 0, we also find the y, the x, and the 2y over the s squared at 3, 2. At 3, 2. Yeah, this is 2-in-1 question, and this question is simply implicit differentiation. I've already explained what an implicit function is. Any function whereby the dependent and the independent variable acts as a subject of that function is called implicit function. Okay, whereby y, x, and y, if you notice, x and y are clustered together in one side of the function, or x and y represent the subject of the function, is called implicit function. So here we also differentiate, and there's a rule for differentiating implicit function. The rule says that whenever we differentiate y, we have to multiply or we add the y dx to it. So the first thing we are asked to find is the y dx, and okay, at 2, 3, and also find the second derivative, which is the 2y over the x squared at that same point, 3, 2. So solution, let's solve the first. Yeah, we want to find the y dx for the first. We are told that x squared plus y squared minus 2s minus 6y plus 5 equals 0. Let me just go straight to the point. Differentiating x squared will give us 2x. Differentiating y squared will give us 2y. Then I'll multiply this with the y dx. That is the rule of differentiation, of differentiating an implicit function, that whenever we differentiate y, we have to multiply the result with the y dx. So let's go. Here we have differentiating minus 2s will give us minus 2. Differentiating minus 6s will give us minus 6. Then I will add the y dx to it, plus 0, all equals to 0. When you differentiate a constant 5, the answer is 0. The next is to bring these two as like terms. Okay, I'll bring it as like term because our aim is to find the y dx. So I'm going to bring out 2y, the y dx, minus 6, the y dx, all equals to, then I'll move this to the other side. That will give us 2 minus 2x. So between these two terms, the y dx is common. We have the y dx. I will factor out the y ds, rather, and that will give us 2y minus 6, all equals to 2 minus 2x. The next is to find the y dx. How do we find the y dx? I will look for me to eliminate this expression here by dividing both sides by 2y minus 6. Now, that implies that the y dx, which is our first derivative, will be 2 minus 2x divided by 2y minus 6. I can decide to factor out what is common among these two terms. Here we have the y dx equals to 2 is common here. We have 2 in bracket, 1 minus x divided by 2 is also common here. We have 2 y minus 3. So 2 can go with 2 here. That means that the y dx is equals to 1 minus x divided by y minus 3. This is the first answer, which is the y dx. But we also find the slope, the y dx, at a given point, 3, 2. So I'm going to say at 3, 2, the y dx is going to be, it simply means I'm going to put my value of x. This implies that x is 3, y is equals to 2. Whenever we're given a point like this, a coordinate point, the first number represents x. The second represents what? Y. So this will give us, let's put the value here. We have 1 minus 3 divided by y is 2. We have 2 minus 3. And that will give us minus 2 divided by minus 1. Our answer here is 2. So that means our dy dx at 3, 2 is equals to what? 2. But the next question says we should also find the second derivative. Whenever you see this, the 2y over the x squared, this means second derivative function. The y dx means first derivative function. But at the same point, don't forget. So let's solve. So what do we do? We have to recall, number 2, let's find the 2y over the x squared. We have to recall that our dy dx is equals to 1 minus x divided by y minus 3. Now, how do we differentiate this? I'm going to use what we call quotient rule of differentiation. In a quotient, we have that if y equals to a divided by b, the rule says what? The y dx is equals to, I'll keep b constant, then differentiate a, the a dx, minus keep a constant, differentiate b, the b dx, then all divided by what? B squared. Meaning I will not differentiate b, I will differentiate a, minus, I will not differentiate a, I will differentiate b, then divided by what? B squared. In this case here, our a is 1 minus x, our b is y minus 3. Don't forget that even in the first derivative, this expression is implicit in the sense that both x and y are standing as subjects of the function. So whenever we differentiate the value of y, I will still have to multiply the result with the y dx. So let's apply the principle of quotient rule here to differentiate this and see what will be the result. Sorry. Okay. So here, our d2y over the x squared is going to give us, in the quotient rule, I'll keep this constant, y minus 3 constant. Differentiate 1 minus x, the answer is minus 1. The rule says when you differentiate, you subtract. I will keep this constant now, 1 minus x. Differentiate y minus 3. The result is 1, but I'll multiply with the y, the what? The x. Don't forget, anytime we differentiate y under implicit, we have to multiply the result by the y dx. We kept this constant first, which is y minus 3. Differentiated this, we have minus 1. Minus, we kept this constant again. Then differentiated this, that will give us what? 1. Then the y dx. Then divided by y minus 3 all squared. Therefore, let's finish up this. The 2y over the x squared will then be, here we have y minus 3. Let's expand this. Minus 1 times y, or y times minus 1 is what? Minus y. Minus 3 times 1 is what? Plus 3. Yeah, I can also expand this as 1 times the whole of this remains this, right? So this is same as minus 1 plus x. Minus times plus is minus 1. Minus times minus x is what? Plus x. Don't forget. All right. Okay, let me say this because to avoid, let me put my bracket to avoid mistake. Here we already have that here is minus y plus 3. All right, minus in bracket. So here we have minus 1 times 1 is still 1, right? Here we have 1 minus x. Then we have the y, the what here? The x. Don't forget, all I just did there is to multiply this with 1 to give us this first. Then all divided by y minus what? 3. All what? All squared. Now, the next thing we need to do is to recall some certain things here. Don't forget that we are told that our point is, I guess, 2,3. 3,2 rather. Our point is 3,2. And our dy dx we solve is 2. Recall this. So I can put the value of this, the whole of this, into this expression. That will give us our dy, our d2y over dx squared equals to. So let's put our y is here, our x remains 3, y remains 2. So let's put the value. Here we have minus 2 plus 3 minus, in bracket, 1 minus 3 all times dy dx here. Our dy dx is 2. So times 2. All divided by y is still 2. We have 2 minus 3 all squared. So let's evaluate this. So we have the 2y over the s squared to be equals to minus 2 plus 3 is 1. Here we have minus 1 minus 3 is minus 2, right? Minus 2 times 2 is what? Is minus 4. The minus times minus is what? Is plus. So we have plus 4. I hope this is clear. Let me explain again. Minus 2 plus 3 is 1. Here we have 1 minus 3, which is minus 2. Minus 2 times minus is what? Is 2. So 2 times 2 is what? Is 4. All divided by 2 minus 3 is minus 1. All to the power of what? 2. So the 2y over the s squared will then be 5 divided by 1. The answer here is what? Is 5. Final answer is 5 for this.